All right, let's gotta work on this together. Hopefully, got a good start. Good table partners. Some of you didn't even say a word. So confident in your definition, Alana. Didn't even have to say a word, did you? 16. Tessa, got this. Anybody want to start us off? Definition of a circle.
There's no angle measures.
Huh?
There's no angle measures.
Okay.
It has like a constant radius all the way around.
Yeah. That's good. That's good. Anybody else? Want to add to it? I mean, we do it all the time. Don't overcomplicate it. What if I say, all right, class, circle up, and I'm in the middle? What do you automatically do if I say circle up?
Go around.
You go around me, and you're all the same distance from the center, right? Equal distance from the center. And Levi, that's called the radius. So if you want to get really nerdy, you can use some new words. All right, the college definition. Let me actually define a word first for you guys to understand this definition. The locus, L-O-C-U-S, not locust, not those things in the trees that make an annoying sound. All right, locus, L-O-C-U-S, is like a collection of all. So if I say it's the locus of all points equidistant from the center, it's the collection of all the points possible that go around in a circle, equidistant from the center, meaning they're using a radius. Okay? Now, if I were to draw a circle and ask you how many points, if I say it's the locus of all points equidistant from the center, how many points? Don't be fooled. How many points are on the circle? I hear none. I didn't say it was right. I said I heard none.
A lot.
A lot. Infinitely many, yes.
We're like the complete opposite.
We don't ever stop and think about this, and I'm going to, I wish I had more time to discuss this. Guys, I need you to listen. Do you agree this is a point? Nope, that's not it. This is a point on the circle. Here's another point on the circle. Here's another point on the circle. And what happens is, if you put enough points on the circle, you're tracing the circle, right? I don't know if your Algebra 1 teacher ever told you this. It's going to come back up in calculus if you choose to take it. Sounds like a mission, should you choose to accept it. We call this the x-axis. How many points are on the x-axis? Okay. How about at 1 on the number line? At 2, at 3, at 4, at 5, at 6. Okay, all the counting numbers. What about all the fractions? Proper fractions? Improper fractions? 1/2? 1.5? 2.5? Do you see how if I start going through all the types of numbers, I will shade in the whole number line? Radical 2, radical 3, those are called irrational numbers. If I name enough types of numbers, I'm going to shade in the whole number line. It's called the real number line. All real numbers. It's the collection. The x-axis is the collection of all points. Counting numbers, whole numbers, integers, irrational numbers, rational numbers, all of those. So what's a circle? It's the collection of all points the same distance from the center. Okay? So if we're going to define a circle, we're not going to use the word locus. That's more of a college term. All right? We don't need to be that nerdy yet. Is this one of your fill-ins?
Yeah. I'll just say circle.
The collection of all points equidistant from the center. Collection of all points equidistant from the center. And a circle is named by its center. All right, now let's remind ourselves what parts of the circle are called. I know you've heard some of these. Some of them might be new. We've heard of a diameter, haven't we? Okay. Have we heard of a chord? C-H-O-R-D. Heard of it? In a circle or like in a chord like instrument? Okay. A chord is the one, it's a segment that touches the circle twice. Okay. So I'm actually going to fill that one in first, and I'll tell you why here in a minute. A segment that touches the circle. Now, the reason why I'm going to define that one first is to know what a diameter is. What's the difference between a chord and a diameter? The diameter has to go through the middle. So the diameter is a chord that goes to the center of the circle. Chord that goes to the center. All right, a radius, half of a diameter, good. Let's define it, though, on its own. A radius is a, can we call a radius a chord? No, it's a segment, though, isn't it? A segment that stretches from the center to the edge of the circle. On to secant. Is a secant a segment? Ray? Line? A secant is a line, isn't it? You see how it goes on forever? It's got arrows. A line that touches the circle. How many times? Twice. Is that red typing big enough for you guys in the back to see? Is that right? A tangent is what? A line that touches the circle. How many times? Once. Thank you. She's actually not here today.
She isn't? I got it.
So these are terms you need to be familiar with, comfortable with, able to explain on your own. All right? All right, we're going to do this next part quickly, just so we can move on to some of the more interesting, complicated stuff. Section's not that bad, but there's one part I want to make sure we get through some examples of. All right, tell whether each line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. All right, you don't have to raise your hand. We're going to go through this quickly. Go ahead and shout it out. AC. Radius. I can spell radius. B is a segment AB. Diameter. What if someone put a chord? Is a diameter a chord? Yeah, it's just a specific one, right? So what if I like never learned your names this year and I said, hey, student 1, or hey, student, like every one of you are students, but you have a specific name. I'm going to call you the most specific name, right? Yes? So I'm not going to say, oh, look, hi, chord. No, you're a diameter. You're a specific chord. You want a name that's more specific than just chord, all right? So AB gets the name of diameter. How about DE? Tangent. How about AE? Secant. Good. Everybody see that? Callie.
So, to the left of the C, that's the symbol for circle.
Yep, that's called circle C. Circle C. Named by its center. All right, now types of tangents. Types of tangency. All right. So here's the ways that circles can intersect. Here's the ways that circles can intersect. Okay. The first one, the blue one, is when two circles intersect and they're different sizes. They intersect at those 2 points. Okay. The next one is they have one point of intersection and they're called tangent circles. I'll explain it, then I'll be more specific with you. The next one is no points of intersection. No points of intersection. And when two circles have the same center, they're called concentric. Concentric. I think of like those Russian nesting dolls. Have you seen those? Like you keep opening them up, and you got smaller ones inside of smaller ones inside of smaller ones. Those are called concentric dolls. Like there's always one inside of another side of another. These are like concentric circles, ones inside of another. They share the same center. Now, we use the word tangent circles because they touch once. These circles are tangent circles because they touch once. Doesn't a tangent line touch the circle once? Makes sense that we call those tangent circles. Good? All right. Tell how many common tangents the circles have and draw them. How many common tangents do these two circles have for A? None. 0. None. B. Yeah, so we on the last slide we called that an internally tangent pair. And if you were to draw it in, you would draw it there. So state whether the tangents are external or internal. So there's one tangent, one internal tangent. Oh, I guess I answered both in that one sentence. They're one and they're internal. All right, next one. What do we call that one? 2 points of intersection. External tangents or internal tangents? Internal? Yep. This book might define it a little differently, so I'm going to look at that one. The other book would also show a little bit more. I don't want to confuse you, but these circles, talking about them touching, they touch internally. you could draw a line that touches both circles. Can you see this line? That would be a tangent line to both. Okay. Our old book would kind of describe that. This is not going to be a lesson that we build too much on these internal tangents, external tangents, except for when we go to set up some equations later in the lesson. All right. But the names of them aren't going to be too critical. All right. This is a big one right here. You might want to put a star next to this. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius. So a line is tangent to a circle if and only if the line is perpendicular to a radius. Is that pretty straightforward, or is that kind of confusing? Awesome. Be honest with me. Is this kind of confusing, or does this make sense? All right. I'm looking like you need some more explanation. Let's break it down. What's QP called? Name it. QP is a radius. Line M is called a tangent. Here's what this is saying. Anytime a radius is drawn that touches a tangent, guaranteed to be at a 90-degree angle there. Guaranteed. Let me show you. Now, bear with me. My drawings are not amazing. Ready? Circle. If I draw in a radius, if I draw in a tangent, ready? Is this tangent perpendicular to that radius? No, because it needs to be drawn at the radius's, be careful, radius's endpoint. Oh, okay. So let's take this and put this tangent at the endpoint of that radius. Oh, what do you notice? It forms a right angle every single time. Okay? If the tangent touches the circle at the radius's endpoint, guaranteed to be a right angle there. And when you see right angles, you might start to see triangles drawn from them, where to solve for parts of those triangles, we're going to need some Chapter 9 stuff. SOHCAHTOA, Pythagorean theorem. Oh, wait a minute. Now, okay, what is PT called? Radius. What is ST called? Tangent. It's just not drawn forever. It's a tangent segment. All right? Now here's the deal. Do we know for sure that this is called a tangent? I mean, it looks like it. It looks like it. But they stopped the picture. They didn't keep drawing it through. So how can we find out if ST is a tangent? Well, if they meet at a right angle, then ST must have been a tangent. Do you follow that logic? How can we find out if this angle is a right angle? Pythagorean theorem. Very good. Now, if it's the Pythagorean theorem, which one would be called the C side? 37. Good. Is 37 squared, question mark, greater than, less than, equal to 35 squared plus 12 squared? We're going to need our calculators today. Remember, we like to put our C squared first. What sign goes there? Equals, and if a squared plus b squared equals c squared, this angle must have been this triangle must have been a right triangle. That angle would have been the right angle. So yes, by the converse of the Pythagorean theorem. By the converse of the Pythagorean theorem. Now, if they told us it's a right angle there, then we could use the regular Pythagorean theorem, right, to solve for one of the missing sides. But they're all given to us. We just had to test to see if it's a right triangle. All right, this one's a little spicier. You did? Okay. All right, in the diagram, point B is a point of tangency. Boom, right there. We just gained a lot of information about this problem. You ready? If B is a point of tangency, then AB is called a tangent. CB is called a radius. And whenever a radius hits a tangent, it forms a 90-degree angle, right triangle. So how are we going to find R? We can use the Pythagorean theorem, can't we? Who's brave enough to set it up for me? Jackson's ready. He's ready for some spice. He's got some milk right by his side to cool down the mouth.
Got some 80 squared plus r squared equals 50 squared.
Equals what?
50 squared.
So close. Let's help him out. A little too spicy for him.
Oh, 50 plus r squared.
Like this?
I would put that in parentheses.
I would too. Like that?
Yes.
Do you guys agree?
Yes.
Yeah?
Yeah.
Only either I didn't write the square there or it disappeared. Everybody see that? It should be 80 squared. 80 squared. I'll blame it on the smart board. It's probably my fault though. All right, 80 squared. 6,400 plus r squared equals. All right, make your Algebra 1 teachers proud. What do you get when you square 50 plus r? Question. I'm going to give you guys a couple options. This is a multiple choice problem now. Can I square 50, square r, and add them together? Who votes yes? That's fine. Go ahead and do it. Nobody's going to be running down the hallway screaming. None of your former math teachers will come screaming. It's allowed, legal. None of you. Paige, you say it's okay? Who says no, that's illegal, and I have something else you should do instead? Tally?
I have a question.
Oh, sure.
Do you mean like leave the plus sign there, or do you mean like actually add them together?
No, I mean like you can't combine 50 and r by addition, right?
Yeah.
I can't say that's 50r. I'm saying is 50 plus r squared 50 squared plus r squared. Yes?
Yeah.
We can't spend forever on this, although I wish we could. Here's my question. And this is going to be true through all of your math career, however long it lasts. All right? Whoa, why was that a boom roasted moment? No, listen. Some of you might go into a math profession. Christiana, you might be like Mr. Westfall and take 16 math classes in college. No?
That's why I got my
I
bonus got a
watched the
calculator in
music
there.
movie yesterday. That's why I'm
You've learned nothing, have you, Levi?
Yeah. I've learned a bit.
He's gotten a little smarter.
A little bit.
Are you guys? Let me ask you this: are you in that mindset? Is if a computer or calculator can do it, then I don't need to learn it? I'm asking. Be honest. It's okay. I won't be offended right now. I'll cry later.
A little bit.
A little bit.
History
You guys understand why that's not helpful?
Yeah. I mean, if you're so bad, you can do it for me.
Huh, interesting.
There's a reason that obesity.
Oh yeah, there's stuff that can solve those for us. All right, maybe back to this. Guys, I need you to listen quickly. If you forget an algebra rule, test it with numbers. Okay? What's 3 plus 5 squared? Okay, I'm going to do it two ways. The way I know for sure is right would be to combine like terms. Now, this one I can't. I'm just testing to see if the rule I'm going to use works, right? What's 3 plus 5? 8. What's 8 squared? 64 is the right answer here. Now, I want to test what we think might work. Are you ready? What's 3 squared? What's 5 squared? What's 9 plus 25? 34. Does that work? Does that rule work? No. So 50 squared plus r squared is wrong. Do you see how you could check that on your own and make sure if you ever forget? All right. $50 plus r squared. What happens when you square something? You are multiplying it by itself. So technically, it's 50 plus r times 50 plus r. Yes? How do you solve that? FOIL. Very good. Or if you forget FOIL, it's the distributive property twice. Oh, don't freak out about FOIL. Oh, really? All right. Here we go. Distributive property. Guys, you forgot. You need to listen. All right. Distributive property. Ready? We're going to distribute 50 to both terms. Then we're going to distribute r to both terms. That's all foiling is. What's 50 times 50? 2,500 plus 50 r. Then we're going to distribute the r to both terms. Plus 50r plus r squared. So what goes over here? 2,500 plus 100r plus r squared. Thank you. Combine like terms. You are very fortunate, friends. Yes. What's going to happen to the r's? R squareds.
Cancel each other.
They cancel, which means you don't need to solve this using factoring of a trinomial or the quadratic formula. Have you learned the quadratic formula?
No.
Negative b plus minus square root of b squared minus 4ac over 2a. All right, 6,400 minus 2,500 is 3,900. 3,900 equals 100r. To get r by itself, we're going to divide by 100. Don't type it in your calculator. What happens when you divide 3,900 divided by 100? 39. Just type it in a calculator. It can do it. Next time you go in for an operation that's very serious and life-threatening, look the doctor in the eye and tell them, if there's a computer that can do this, just have it do it instead.
Well, that's different. That's like
It's not.
risking my life.
No, they actually have
One of them is clear.
And actually, my mother works for a company that designs
The stakes are
No,
very
and those are great, but the doctor is the one that controls them. And if they copped out on every single one of their medical exams, all through medical school, and typed everything into a computer and said, I forget what this thing's called. I hope it's called this.
Well, you might die.
You might die. All right, external tangent congruence theorem. This is the next theorem we need to know. Quiet, please. If two tangent segments. Now, you need to understand where this originates. Ready? Tangent segment. It gets drawn out into space. It used to be a tangent line. This used to be a tangent line. But then they cross. So now we're going to stop them at S. We're going to stop them and say, don't go on forever. Just stop at S. Those are now called externally tangent segments. There are some really cool implications of this with GPS signals and satellites and all that kind of stuff. What if that's Earth and you're in outer space at point S? Isn't R and T, isn't that the extreme parts of the Earth that you can see from your eyes?
What if the Earth's made flat?
I'm starting to see a bigger picture of Levi Rockfish. Like, it's all getting real. All right. And we don't have time for that. All right. RS is tangent to circle C at S, and RT is tangent to circle C at T. Oh, look, they meet at R. What's the theorem tell us? If you see two tangents to the same circle and they cross, they are congruent. Very good. They are congruent. That was the theorem we just talked about. They're congruent. So we can solve for x by setting these equal. Three x is 24. X is 8. Have you guys heard about Starlink and what's the dude's name that makes the Teslas? Musk. Have you guys heard about Starlink?
Yeah.
They're putting dozens and dozens and dozens of satellites out there.
He thinks that computers are smarter than humans.
I mean,
To add to the conversation.
Elon Musk's computer.
let me ask you a question though. Levi, let me ask you a question. All right, you're in a self-driving car, and it's, let's say the computer in the car is smarter than a human being.
Oh, I still don't trust that.
Yeah, I wouldn't trust him.
I agree. I wouldn't trust that car with my
But
life.
you said computers can drive. If they can drive, then they should do it for
I
us.
say they can drive.
Based on your argument, if a computer can do it, it should do it.
Well, I would
Just like
rather,
our
Go ahead and solve this one while I argue with Levi.
But like,
Hold on a second. For the sake of time, let me just get straight through the argument. A self-driving Tesla is driving down the road at 60 miles per hour. Okay? There are two people in the middle of the road. Okay? One in each lane. Okay? And this is gonna get really dark, so I apologize. One of them is a baby.
Oh my god.
One of them is a 95-year-old.
oh, she's living her life.
Which one is the Tesla does not have a choice. It cannot stop. Should it make a decision?
Oh, the old person, because the little kid's got a life to live.
How would the Tesla make that decision?
I don't know. Maybe it's got
And I don't have an answer. I'm just saying. I'm saying that's the
or
question.
like
We actually finished it.
yeah, what if it's saying
That is like
What's that, 12? X equals 12. Did you guys all get x equals 12? All right. Are you seriously going to complain about homework?
Yes.
Yes.
Always.
Why not?
No, not everyone wants to complain yet.
I love homework.
Oh, I'm sorry. I'm sorry. Did I give you guys 7 minutes to start it?
No.
Hey, if you want to spend 7 minutes complaining, there's the hallway. All right? Go ahead, Chase. See you guys. But do you see what I'm saying about the component of
Yeah, but
individual thought and reasoning?
what if you leave him with
It's not possible.
What if it's also raining and it's a human driving? and say the car slips and you go into a drift and accidentally hit both of them.
Then the computer couldn't have overridden that.
Exactly.
A drift is a drift. No, a drift is an uncontrolled slide. By definition.
Well, no, you can't do
So you can do a controlled drift. I can too. Can a Tesla do a controlled drift?
Well,
If the moral of the story,
figuring it out.
you do not react fast enough
Elon's putting
unless you're 90 years old. Like the humans that put everything into things.
But like, what I'm saying is like, I'd rather trust a computer with like a basic